Good morning, everybody. Today's topic is software engineering. You all might be knowing what is engineering. Engineering is an art of creating new things or developing new things. Software engineering is also of same kind. We are going to develop a software using new methodologies or new techniques, or that is called as software engineering. So first we'll move on to the definition of software engineering. So everybody might be thinking, what is software and what is a program? So program collection of different programs to have an end application is called as a software. Okay. Now we come to software engineering. So it is the application of a systematic, disciplined, quantifiable approach for the development, operation, and maintenance of software. So here I have categorize the definition into two parts. One is how we have to do it. That is, it should be a application of systematic methods and disciplined approach and quantifiable approach. So you have to make your software engineering process systematic by having clear-cut definition of things to be happened, and it should be disciplined, that is time bound and quantifiable. All those things are needed for the development of software. So systematic, disciplined, quantifiable approach for what? For the development, operation and maintenance. It is not just developing software. You should include how the operation would be, how you have to maintain software. So all these things together is called as a software engineering. So this is the definition given by IEEE, an international organization for software engineering. So, as I have told that software engineering is a systematic and disciplined approach, definitely it should have clear-cut stages. The main stages which are included in software engineering process are requirements, design, coding and testing. Okay. So, you could see the diagram which clearly shows step after step that your stages of software engineering. Okay. The developmental methodologies which are commonly used for software engineering are waterfall development, iterative methodologies, heavyweight methodologies, and agile methodologies, and extreme programming. Extreme means extreme programming. Okay. So we'll see these stages very clearly. Software development includes the following activities, that is, or the following stages. The first step would be requirement analysis, followed by design, coding, testing, and maintenance. But the main thing to note here is these activities do not follow strictly one after another. They often overlap and interact. What do you mean by that? So it is not that the design, while performing requirement analysis, you complete requirement analysis, then you move on to design. While doing your design, if you find that few requirements are missing, or if you find that few requirements have some errors or changes needed, then you go back to the requirement analysis stage. You collect the requirements, or you add the new requirements, or whatever changes you need, you do it there. Then again come back and design with the altered requirements. Then you come to the coding phase, where in coding also, if you find some mistakes or additions needed in design phase or requirement phase, you again travel back to the previous stages. You do your changes whichever needed. The fourth stage testing, it clearly to be noted here that testing doesn't follow only coding. Testing starts from your requirement analysis phase itself. So while doing requirement analysis itself, we start checking that whether our requirements are correct, whether we are as per the plan, all those things we do it in the requirement analysis phase itself. So it is not that all the stages will be as per the alignment. So they often overlap and interact with each other to have a full-fledged software. I think this would make you clear on the developmental stages of software engineering. Yeah, coming to this diagram, which clearly shows how software development should happen. So, say I want to build a small raft. A small raft is nothing but a small boat by which I want to escape from the island where I have been caught, and I want to reach the shore. Okay. So here I was not given any specification how to develop a raft. So how I have created, I have made a post, and then would I have placed it on that. How could I travel with this? So without specification, the end product will be a failure. Next is no funding. So I don't have any funding. So if I don't have any funding, I cannot do anything. So I cannot build any product out of it. Say the next one, no quality assurance. So there is no process of checking my quality. In that case, my product will end up in failure. See, he is sinking in the sea. Okay. See, next one is no market research has been done. They have not analyzed that whether any ship is coming to be near the island, or is there any other possibilities to escape. In that case, if they have done some market research, they need not have spent their time and money in developing a raft to get out of this island. Next one is no deadline. So since there is no deadline, it has been end up in failure. You will not complete your project at all in time. Okay. Then if there is no demand, there is no need for a raft inside a house. Am I right? So in that case, your product will also be not sold in the market. So to build a product or build a software, you should have clear specifications, you should have funding, you should have done quality assurance, you should do clear market research, and you should have clear deadlines, and it should be a product of demand in the market. So these are the things which we should have in mind while developing a software. Okay. With this I conclude today's lecture. In tomorrow's class we'll see about requirement analysis and how that requirement analysis phase starts and how it travels to end of collection of requirements. Thank you. Have a good day.